So we were able to discuss a little bit the alternatives that we have to characterize the patterns of land use changes, how to study the drivers from the human and the biophysical dimension, and the ways to look at the consequences. You probably get an idea that analyzing the consequences is way harder than understanding the drivers, because they are not just looking at the consequences or the consequences varied depending on which part of the society, on which actors are we focusing on. So the approaches to do that are pretty diverse. I present one, the idea of, or the conceptual framework of ecosystem services. And within the conceptual framework of ecosystem services, I concentrate myself in presenting the approach based on biophysical evaluation, quantification of ecosystem services. Actually, I did something else. I criticized the other approaches. So we got a discussion on this. I want to now discuss a little bit on some alternatives to start to see the feedbacks between the consequences of land use changes and the drivers of land use changes. And this is something that has been way less explored than the other things. If we got problems in understanding these flags here, the drivers and the consequences, understanding the feedbacks is even more complicated. And I'm going to go through one example that relate the relationship between land cover and climate. And this is not one-way direction. There are continuous feedbacks between changes in climate and changes in land cover, climate as a driver of changes in land cover, or determining changes in land cover, or all the way around. I will say, let's study how changes in land cover impact on climate. And I will focus not on something that it's not my business, climate models, but on how we can make climate models and land use change talk. So a way to communicate between these two dimensions, the climatic and the land use change. And the way to communicate is this acronym there that is for ecosystem functional types. We got a problem in characterizing the land cover and the vegetation patterns, because this is a pretty dynamic issue. So areas get deforested, and so we need to get more field data, or looking at many high-resolution images. And actually, we are also missing part of the information. All the forests interact with climate in the same way. All the possible transformations of the land interact with climate in the same way. Put it in other terms, the changes that occur in a cover always has the same albedo, always determine the same changes in the exchange of water, carbon, momentum with the atmosphere? Clearly not. There is a variety and depend on many things. It depends on if we replace forest by a pasture, or if we replace forest by a soybean, or if this soybean is planted, I don't know, in October, or is planted in December. So one way to characterize the surface of the earth, instead of using structural attributes, what is there, a plant that we call it soybean, or a formation that we call forest, is characterized in terms of functioning. That it means that we define a piece of land based on how exchange energy and matter with the atmosphere. Let's translate this a little bit more. And let me go back to, no, it wasn't there, but no. Do you remember we were talking in the afternoon on this index of provision of ecosystem services? And I put a graph in the screen that show how change the carbon gains or a vegetation index through time, through 1 year. We may have a curve that is more or less a normal curve. We may have a description that everything is flat, very high or low. We can have a skew kind of normal, not normal, skew distribution or dynamic of this that got the peak late in the season or early in the season. We can have more than one peak. So we got a variety of shape that provide what we may call a phenological signature of a piece of land. I'm clear with that or not? I will do that, yeah. This one. And what I'm saying, this is representing a forest that start to grow here or start to sprout here, got the maximum leaf area there, and start to senesce in this part. Got this shape. Let's imagine another system. One system that, for example, get less variability. So the curve, it will be like this, or with a little bump in the middle. There will be some other stuff that get nothing in part of the year and a peak and goes down again. Some of them will have the peak here. Some of them will have the peak earlier or later. So this curve describes what in biology called the phenology of the vegetation. Phenology is how things, biological things, change through times, mainly associated with seasons. So we may see different aspects of the phenology. For example, the production of buds, the production of fruits, the production of flowers. One thing that we are seeing is the dynamic of the leaf area. So we are seeing through a spectral index that it is possible to track using remote sensing the phenology of leaf area index, what we can say, tell us something about the phenology of the carbon gains. So, if we look for a particular piece of land, let's say a pixel in a satellite image, this curve provides something that we may call the phenological signature of a piece of land. This is, I don't know, if some of you are familiar with remote sensing technique, perhaps you listen about the spectral signature, some of them. This is an analogous concept, but it's not looking through the electromagnetic spectrum, but it's looking through time, through seasons, through a growing season, to see how things change and provide a description of the way that this particular ecosystem interact with the environment. Of course, this particular signature will depend on the dynamic of the temperature, the dynamic of the radiation, the precipitation, frost, management, what we as humans are doing on, on those systems. Having this idea of phenological signature, we come up with another idea that, well, as we do when we classify a satellite image or when we classify anything, let's lump together all the parts of the land that get the same or a similar signature. So, for example, let's get all the pixels or pieces of land that get a very variable dynamic through the year and a peak here, and on the other side, let's get another group of pixels that get a even value of leaf area index, carbon gains through the years. I'm clear with that? How we call these two groups? I was in the other PowerPoint. Sorry. I have the picture down there. Well, sorry. We call it ecosystem functional types. What are the ecosystem functional types? Are group of ecosystems that share functional characteristics. For example, the exchange of matter and energy between the biota and the physical environment. And we are here with the same type of graph showing the phenological signature. If we analyze, as I already told you, the phenological signatures for many different ecosystems all over the world. What is possible, because we got satellite data for the whole world. And we try to, using some multivariate techniques, try to get what are the dimensions or the descriptors of this curve that capture most of the variability. We end up with three attributes of this curve. We already talked about two of them. The area under the curve, the range of variation, and the third one, the time of the year when the system gets the peak. So let's thinking on the third dimension that I incorporate, let's get the specular image of this graph. So we may have the same variability, the same area under the curve, but the peak, instead of being here, if we just make the specular image, we get the peak here. Instead of having in April, we get it in September or October. So, why is important this? Because with these 3 dimensions, we are able to characterize the spatial and temporal variability in ecosystem functioning. Well, I will say in one aspect of ecosystem function, mainly related with carbon gains, from many, many different types of ecosystems. And we can capture the effect of, 1, different environmental conditions, the difference between São Paulo and Buenos Aires. But also we are able to capture the differences between São Paulo today and São Paulo 5 years ago, because the amount of precipitation was different, because the cold fronts that get from the south got a different dynamics, or so on. And we are also able to capture the impact of the intervention that we did on the ecosystems. For example, changing the land use. If we got a piece of cerrado, well, in São Paulo there are not much cerrado left, no? But in some places where we still have some cerrado, we can see the changes associated to a remotion of cerrado due to expansion of agriculture. So there was kind of quite a lot of work with different colleagues working on this idea of ecosystem functional type, basically describing these 3 dimensions. This is a map of the variation in the area under the curve. So there are areas with high values here in the Amazon, very low values here in Patagonia, or in the ice field in Chile. We got a variation associated with this seasonality, described with the coefficient of variation, that got areas with high values, for example, here in the deciduous forest of Chile and Argentina, some very low values in this area that are grassland that get green almost everywhere, and some areas where we start to get some high value spot associated with agriculture, for example. And here we got a description of the month where we get the highest value. Of course, most of the values are concentrated in the summer and spring summer and spring season. If we combine this, and this, we come up with a description that integrates these 3 dimensions, 3 attributes of the curves, and provide a base to lump together areas which have the same behavior. I don't know if you see it from back there, but here is the legend of this map with different colors, and I will show you what it means. The point is that to do the classification, we may take different approaches. We may use many, many different fancy techniques to classify data. In this case, we take a fixed model approach. We divide the total variability of each of these dimensions in 4, and we combine these 4 classes. We end up with 64 possible classes to describe the functional variability of the ecosystems. And we may name. Then you may ask, why do you use this approach instead of using a fancy classification technique, and I will answer this question later. We come up with a classification with 64 classes that can get named not based on the structure that they have. We don't have classes that are crops, bare soil, forest, or xerophytic forest, humid forest, grassland, or so on. No, we have classes that we name AA1. What it means that? The first letter means A, B, C, or D means the value of the total amount of carbon fixed by these ecosystems. A are the ecosystems that fix more carbon. D are those that fix, all the way around. A are the ones that fix less carbon, and D are those that fix more carbon. The second letter tells us what is the seasonality. Very low seasonality up to very high seasonality. And the number tells something about the timing of the peak. One is spring, summer, autumn, fall, and winter. So there is a lot of things going around with this. For example, this paper from Domingo Alcaraz, that is from Andalusia, analyzing the ways we can get ecosystem functional types, the different approach, the advantages and the problems, and the way we understand the patterns and so on. In this case, I want to concentrate on my goal, that is showing the feedbacks between climate and land cover changes. What has happened is that we start to have some collaboration, basically related with this CRN project, with people that work on modeling the climate. Ugo Berberi from the University of Maryland, and we got this discussion around the way that land cover get incorporated into the climate models. And I don't know, probably some of you guys are more familiar than me, that they're incorporated in a very static way. There are some parameters that define a scenario of land use that drives the simulations. What Hugo did was changing the way that the surface is described in these models, incorporating the idea of ecosystem functional types. Because a change in function means that all these parameters that determine the interaction between the surface and the atmosphere change. Change the way, change the stomal conductance of the canopy, change the root distribution in the profile, change the exchange of momentum, and so on. So, based on a description for every year of the ecosystem functional type, Hugo Berberi and Omar Mueller, that work with Agostina, that is here in the second row, get an estimate for each of the ecosystem functional type of the physical properties of the surface. Which one? I think that we have some example here. For example, the stomatal conductance, the minimum leaf area index that this system may get, and there are many others. I don't know. I will say I don't have it quite in mind, but there will be 15 or so parameters needed to run the models. And run the model, the weather research and forecasting models. Probably, again, you are familiar with those regional models, and analyze, in this case, the difference in simulations between the runs made using the ecosystem functional types, that means changes through times, a more detailed description of the spatial heterogeneity, because now you don't have just grasslands, you got the difference that this grassland got in the timing of the primary production or the carbon gains, the total amount of carbon gains, or the seasonality of the carbon gains, and a control based on the original description of the land surface parameters. And what I get is an opportunity to understand better the interactions between land use change and climate. How they see it? Well, basically looking at the changes in positive and negative biases with actual data in the runs based on ecosystem functional types. So we got a way to understand how land use changes and its consequences on what? In how the system works. So you remember my box with the human or drivers and consequences, human and biophysical, how the things that are in the right hand side in the bottom of the scheme impact on one of the drivers, climate. So this is an approach that tells us how, one example, how to understand the feedbacks from the consequences to the drivers. And with this, I went through all these process of kind of understanding and provide examples on how to deal with all these aspects that we need to understand in this dynamic of land use change, drivers, and consequences. Now, to finish, we have some time, not much. At what time do we finish? At 6? 5:30? Okay. What, 5? You're going to... I may understand perfectly, because I'm tired too. You got an advantage over me. You were seated. I was standing. Well, so, we got some time. Let's go back to this idea on which we start, is the socio-ecological system and how we characterize them. Because we need, again, a way to describe the socio-ecological systems. And if this system, this scheme is basically the same that the one that I show you on Riedman. We got a social system, an ecological system, and we got the interactions in between. And we need to know if systems, socio-ecological systems, are changing, if socio-ecological systems differ over space. For example, all the socio-ecological systems, we know that not, but how the socio-ecological system that we got in the Chaco forest differ across, let's say, provincial borders, or across climatic gradients. How we describe now this entity that is not an ecosystem, that is not just a department. It's something else. It's something that combines the human and the ecological dimension and their interactions. And then we may introduce an idea related with the one that we were discussing just a few minutes ago, the idea of functional types. The idea of functional types is an idea in biology and ecology, well established. We talk about plant functional types from a long time ago. We talk about ancient functional types. There were some people here working with agents that talked to me in agent functional type to describe social systems. Now we're going to combine the description of both the social and the ecological dimension on these socio-ecological functional types, defined at spatial and temporal explicit socio-ecological systems that present similar functioning. Again, like in the case of ecosystem functional types, we are lumping together areas that share some common functioning. In this case, not just on the ecological side, the exchange of matter of energy, but also on demography, on socioeconomic, in cultural patterns, and a similar way of coupling between the social and the ecosystem dimensions. And this is something that require, again, to define the dimensions to characterize this. I know that you cannot read anything. And what we need to do that, based on the definition of a socio-ecological system, is define, on one side, the ecological dimension. So we need descriptors of the structure and the functioning of the ecosystem. We need to define dimensions related with the social part, population, and some descriptor of well-being and development. And also we need to come up with a description of the interactions. We don't want to just these two things separate, because we also want to have the interaction between the social and the ecological dimension. And there we incorporate the demand and provision of ecosystem services, the pressure on the environment, and the connectivity of the system. How well connected are the social and the ecological dimensions. And those dimensions need to be characterized by variables that we need to get somewhere. Some of these variables can be get from, and this is a major problem in this type of things, because there is a kind of dialectic relationship between what we want to have as descriptor and what we can get as descriptors. And usually these things do not match very well. So we may write a letter to Santa Claus asking for the best descriptor possible for what we want to do, but may work. But I know, I have to say that Santa Claus do not exist. So you will not get it that. And you have to get what your parents leave it in the Christmas tree. And, that is the information that you may get from remote sensing, secondary data, and basically secondary data. And this is a process where, in this particular case, you need to summarize information. You need to think carefully on what will be the resolution of your analysis. For example, you cannot get everything at the resolution of a pixel, because most of the secondary data are not defined at this level. To some extent, the definition of the resolution of your analysis or your characterization of the socio-ecological system get defined not by the very basic reasons that you may have, but for the data that you have. And let me go through this process. And in this case, that is not just the semi-arid Chaco, but also the part of the humid Chaco, the resolution of the data is the lowest resolution of the census data, the official census data, the one that get the governmental agency of statistics for, in this case, Argentina. That is not the department, is something smaller called radio censal. Is a measure that is relatively small. And based on this and a description of every variable, first you may start to analyze how these variables relate to each other. So, how the ecological variables, or the variables that describe the ecological dimensions, relate to those variables related with the social dimension and with the interactions. This is an important thing, because one first question on analyzing the system is the dimension associated with the natural capital vary in the same direction than those related with the social capital or the infrastructure capital. And this is a correlation matrix. I don't want to go through each of these cases or correlations, but an interesting result is that we don't get very high correlation. That means those are the highest, 0.6 of R. So, relatively I would say modest correlation between variables. That means that among the variables chosen, there is no redundancy. That means you are describing different aspects of what's going on with the functioning of these systems using these variables. We were not able to do something that we will love, is get rid of most of these variables and represent the ecosystem, the socio-ecological ecosystem functioning using, as in the case of the ecological functional types, using 3 variables. We need to keep this one, all these ones. We classify these variables using some technique. In this case, we don't use this fixed approach that where we divided in 4 each dimension. We perform a hierarchical classification of these units, small units in the Chaco, and come up with a description of the heterogeneity in terms of socio-ecological functioning. We describe 2 levels of socio-ecological systems. The green ones, no, excuse me. Yes, the green ones, the blue ones, and the red ones. And as you see, there are some spatial patterns, and there are also some systems or some groups that are interspersed in between some others. Each of these groups is also subdivided at a different level in subgroups. So among one of the, for example, the green ones, over here we may have extensive cattle systems dominated with cattle breeding dominance, and extensive cattle system with there is also some cropping in there. And the other thing is that we may characterize each of these functional graph with this chart. I don't know what's the name of this type of charts, based on the intensity or the importance of each of the dimensions that we consider. Dimensions related with the ecological system, the social system, and the interactions. What I want to do with that, showing this, is that there is a way, or there are ways, that if we have a clear conceptual definition of a socio-ecological systems, we may describe this ecological system using actual data, which is important because it opens the possibility to compare, to track changes, to see what's going on with all these factors that we know that are operating over the ecosystem, the socio-ecological systems, from land grabbing to global demand for commodities, particular normatives that may change what is going on with deforestation, or with political or with policies of immigration and any other things that we may consider. I'm running out of gas. And this is more or less I got here a low battery. So the alternative, after confessing this, is stop here and give us, I don't know, 40-something minutes to discuss, not just this, whatever we want, we talk during the whole day. I think that more important than adding more stuff is trying to having you guys identify some problems on my reasoning or my ideas, or discussing applications or possibilities that you see from what I show you. What do you think? Better? Okay. You guys, now let's have the discussion. And I'm not used to, I don't like the applauses in a class. I don't know, but I appreciate them. No, I'm not saying that, but this is a class. It's a common construction that we are having. It's not a performance. What are we going to say? Well, no, let's open the discussion, and we may go through any of the topics that we were discussing. So, you want to start?
I don't know.
I will appreciate very much
those
questions that do not go through me necessarily.
Not to everybody.
Okay.
It's a question that we can discuss all together. I don't know. I live in a place of the world where landscapes are not too much used, Patagonia, and maybe now we are receiving some scientists that are coming with these new ideas of agroecology, and that means maybe start to change ecological services, interchange one to the other, And I am concerned about not thinking in the intrinsic values of the ecosystem when we're doing that change. I don't know if you understand what I mean. You know, productivity from one plant situation and take that off and put another thing, and the ecosystem service is going to be the same, but all the structure of the ecosystem is going to change. And well, I think we need to protect the intrinsic values of the ecosystems. So how can we work with these new topics in the areas that are not so much disturbed until now? That is the question.
I have a comment on your comment. And you say something that we need to protect the intrinsic value or whatever. And I throw a question. Who are we? We are the academic sector. Which are our responsibilities on deciding what to protect and what to not protect, and how we deal with this situation? That is something that, well, at least for me, and it's related with these ethical issues that we were talking about. Of course, you can discard my question and go through.
Just a comment. I'm happy to hear today like the other evaluation of environment, not just economical, because what seems strange to me in like the just economical evaluation of environmental values is that sometimes how to say, we put all in like in dollars, euros, what you want, to be more comprehensive to the politician and to discuss about it. But then we compare things very different with the same, how to say, with the same things. Like we use euro to compare, I don't know, the CO2 production and soil moisture and other things. So I'm happy today to have seen another approach. Another approach, yes.
About what you were saying, I have a little afraid when we scientists give us our opinion based on intrinsic value for doing preservation projects or this kind of thing. Because I think that society sees us with a lot of importances. I work in my master in a coastal area, and there it was a conflict of expansion of a harbor, and a lot of people of the academic thought that that area was very important because had a lot of animal species, and this kind of statues, this position of theirs, change the decision-making situation. But sometimes I wonder if it was better or not, if the intrinsic value can change a lot from people, and why our opinion about the intrinsic value is more important than the local community or other stakeholders. Talking with that community in particular, a lot of people argues that the harbor would be good for them because of the employees and other things. So I think that we have to be careful with that and showing this kind of information, the trade-offs, the difference in benefit with different scenarios, trying to stay, I don't know how to say this, but more with not such a strong opinion in what to do, it's a better contribution for this society.
Regarding the approaches that you have discussed today across the sessions, my personal view is science should always be descriptive in nature, not prescriptive. So as long as we can put forth what the intrinsic value is through some scientific experiments or scientific methodology, and let people decide what they value the most, because sometimes what we understand is the value of it is known, that is known to us, is very subjective in nature. And also the fact that what we realize today may or may not be capturing the true value of the resource that we have. We may realize it after complete devastation, after the entire species or the entire nature is lost. So the notion of value, not necessarily in terms of economic value, but the value of its existence itself, may not be appropriately determined through any prescriptive methodology. So it is, in my personal view, always advisable that we it is a direction in which we can put forth. It gives us a sense of direction that if we do something that is going to change our ecosystem in such manner, but not necessarily that we should be prescriptive always that what we should preserve and what we should not preserve. Because if we look back in history, the way evolution has happened, always we probably were not always aware of those importance of those resources, but yet we chose to preserve them, we chose to move ahead with them. So I think it is a debatable and very contentious point to put forth that we as scientists should always come forward and say what should be preserved and what should not be preserved. It should be left to the local community or to the people who derive the value from the resources.
I disagree. As a scientist, you have no power to decide what should be preserved or not. You give your opinion, hopefully it's an informed opinion, and the decision is going to be taken by somebody else. If we look at some of the real decision-making processes, they're guided by governments who get elected. Most of the electorate is in cities, not in the country. Their appreciation of ecosystem function, of land use, is totally different from the realities out in the country. Somebody who thinks that the milk comes out of a carton in the supermarket will have a very different opinion than somebody who knows that the milk comes from a cow that grazes on the countryside and therefore displaces natural ecosystems. So I think rather than putting your light in the shadows and your knowledge as a contribution, well, maybe it should be. I think as a scientist you can come up and say, this is what I believe based on my results should be happening. If we look at the ozone debate, nobody knew and nobody had a means to know that there was a hole of ozone over the poles. Only the scientists could do that. Unless the scientists come forward and say, look, we are having a problem in the future if this goes on, nobody would have signed the convention on the ozone preservation. So I think we are at a stage of complexity in the development and in the global change situation where the scientists have to take on the responsibility to drive certain processes. Nobody will leave it up to you to take any decisions anyway, but you have to make your contributions.
There is related with this point and the one that there are two things. What are our attitude in front of the different type of problems that we face as a society, and what is the role of scientists. And I like it very much, a model that Roger Pilke Jr. present in a book that I think that the name of the book was one of the potential roles for scientists, the honest broker of alternatives or something like that. And basically the point of Roger Pilke was that as a scientist we may take different roles, and all of them are okay. As particularly are okay if you state clearly the positions where you are talking. You can be a pure scientist. So I publish my papers, and my papers are there. Go read it and take the conclusions you want to take from this paper. This is my job. Fine. This, the other role of scientist referee. So the community, the government ask you, what do you think that is better, to build the harbor or not to build the harbor? Or, it's not a good example, which area got more biodiversity, this area and this area? And you provide an answer. This area got more biodiversity. I measured, I estimated, whatever we say. Those approaches imply a little, almost nothing, involvement with stakeholders or with values. Then you may get involved with values and get in the math, I will say. And then you may play a role of advocate of a cause. And so we see many of our colleagues that get a flag, no to the whatever, or yes to, I don't know, mining, industrial agriculture, I don't know. There are many, many examples on which colleagues, with good reasons, get involved in this role of advocate of a cause. And then it appears the other role that we may play, that is, be the honest broker of the alternative that the society may have to find a solution of the problem. Aside from what Holmes said, that is, wow, look at the hole that we have over our heads, so pay attention on this, that is, rising issues that people didn't see because we got access to knowledge and possibilities that people from the public do not have. But the honest broker put over the table the menu of alternatives and say, well, you may do this, this, and this. If you do that, it may happen this. If you do that, it may happen such, and so on. And I like this approach. It's not as easy as you may say it. I'm partly related with something that you said about the descriptive or prescriptive. And there is a trap there. Because sometimes we say something in descriptive terms, but those terms end up being prescriptive. So if you say, well, once you get the Earth with a temperature over 4 degrees, what it happens is that the sea level such and such and the sea current such and such. We are saying something that describes a situation, but is prescribing a way to deal with this situation. We have to do something. If people that receive this information have to do something with the description that you are providing. So, we as a scientist have a kind of complicated role. and it's hard for me. It's hard to get in a particular role of this that Roger Pilk say. I wanna be in the honest broker. I'm not quite sure if gonna be honest in the terms of being neutral. I can be honest. I'm not being neutral because all my statement will be based on my set of values, my ideology, my interest in some terms, legitimate interest in some terms. So there is a challenge. And I don't know if there is a solution. For me, the important thing is think about that and be careful on do not step in something that clearly is not our business. No? That is something that we may say. It's true that we don't take decisions, but sometimes politicians call us to legitimate a decision that is political. And this is a problem because we are not quite sure that it's more important to preserve this area because got more biodiversity. Well, it is possible, but also there is this other area that got less biodiversity, but I don't know what else happened in this area. And making a strong statement on the political arena as a scientist got an impact because it legitimates an action that we don't know if it's actually reflecting the views, the belief, the willings of the whole society. Basically, what I say is that I don't know how to deal with that.
Thank you, Professor. It's a very good point that you brought in, and there is a particular point that I would like to highlight here is that it has been shown, at least in the economic literature, that aggregation of preferences or aggregation of the various tastes and preferences across individual to arrive at a single metric that represents the society is impossible. So in some sense, like when you say that as a scientist, are we representing the true choices of the society? Well, if the theory is to be believed, then it is almost an impossible task.
Yeah.
As nobody has any comments, I thought I would make a comment about the monetization, whatever that word is, of ecosystem services and perhaps the danger of that. And also somebody mentioned in another day of presentations and questions about perhaps the failure of capitalism to deal with these issues. Well, I'm going to just read, it's a very short sentence, well, more or less by Alanis Obamsawamwin. I don't know if I pronounced that correctly. Some of you may already know this kind of proverb by an indigenous American from Canada. So it goes, when the last tree is cut, the last fish is caught, and the last river is polluted, when to breathe the air is sickening, you will realise too late that wealth is not in bank accounts and that you can't eat money. And, well, that's up for comments.
Yeah. I have a comment on this. Of course, we, and this is not a criticism, but this is a sentence that got a profound emotional component. That clearly, I agree that this is true. We as scientists have a different role of play. We as individuals, we are sympathetic with these emotional things, but society requires from us something else. And I don't know if I'm doing it right or not, but the point is that they need elements to take decisions that are objective. What I mean, that science is objective. No, I decided to study land use change because a lot of things that are related with my interests, my beliefs, my ideology, or whatever. But when I decided to study this, I apply protocols that everyone can go and say, well, Jose, you did wrong there and you have to change. Yes, you're right, and I fix it. And provide elements that can be used to take educated, informed decisions. This includes data, this includes conceptual models, this includes protocols. All these things are what the society is demanding us to deal with these kind of emotional issues that even in the social science, the ethical discussion on terms of commoditization or not commoditization is something that we as scientists, not particularly me because I'm not a social scientist or a political philosopher, but those that work in this area have to make clear for the society, to have an opportunity to take informed, educated decisions in terms of that. And then, particularly in this type of course where there are many, many different backgrounds, disciplines, and I talked with biologists, hydrologists, a physician, and agronomists, meteorologists. There are many, many different backgrounds, and there is a message that we have to deal with some care. That is the interdisciplinary work. And sometimes interdisciplinary means no discipline. And this is one of the major mistakes that we can make. We can come to the interdisciplinary work after we are very good in our discipline. And we need to be the best economists, the best agronomists, the best biologists, the best lawyer or whatever before starting to work in the interdiscipline. This means that you have to open your mind, that you need to do this exercise, that interact with people in a way to get a common language, to make the bridges among disciplines. But we need to be careful, do not kind of empty the disciplinary component of the interdiscipline. And we were talking in the coffee break, someone said, oh, I like having equations and numbers on these things on ecosystem services. And actually what I'm doing is working on my discipline. I'm an ecologist. And I try to make bridges with the social sciences. But I try to describe this. You see that you see people talking about ecosystem services that have no idea of what is an ecosystem, or what you can go and measure on an ecosystem, and they just talk on this. And this is kind of a very risky things, because we can have, or what it may happen is that we as a community, and those that really interested in interdiscipline, get kind of devaluated at the eyes of the society. So this is something that in this group I think that is an interesting point for discussion. What are you going to say?
Professor, we talked a lot about communication along those days. And now we talked a lot about communication with decision makers, policy makers. But I would like to add another thing to this debate, which is to communicate with the audience, with the general public, with the taxpayers, if you want, because the pressure for the decision makers come from the general public, from the taxpayers, or I don't know. And I think scientists should think about that as well, not communicate just with the decision makers, but with the public in a common language. That's it. Thank you.
Well, regarding your view about your well-pointed position about the interdisciplinarity, and this is a profound analysis, you know. I think that there's in the interdisciplinarity level, when we start working with, for example, environmental science, there's, as you said, risk that people don't know how to do plain spoken science. Okay, they don't know how to communicate with the people, and either they don't know how to communicate their own ideas to the guy who is in the next side. You know, we're all trying to solve this global warming problem. You know, but we can even have communication. So I think that there's also need. We first, as you said, when we had to remember that we are scientists. Okay, so we had to be stone cold. And get it, don't forget their discipline, and maybe, I don't know, just thinking, well, we need, for this kind of exercise, we need some kind of framework, you know. We need a little bit of help to integrate this other foreign knowledge, you know.
I think we need to be realistic. You just mentioned we need the interdisciplinarity in order to be able to opinionate or pronounce opinions and results about complex conditions in nature. So we need to develop the communication between different disciplines, between different scientists, and now you're asking us to communicate with the public as well. And let's face it, scientists are sometimes called nerds because many of them are nerds. They're happiest when they sit in their laboratory and don't have to talk to anybody other than their computers. That is a reality.
I like this.
And that is just, this little bit of an autistic element is something very common in high caliber, particularly high caliber scientists. And that's part of the reality. In other words, if we want to solve some of these communication problems between the scientists, between scientists and policies, between scientists and the public, we need teams, we need networks. Without that, it cannot be done. So I think the problem is not at the level of the individual scientist or the level of the individual disciplines, but in the way that science is being managed and what resources are given to different scientists, to different disciplines, to take on these responsibilities in society. 200 years ago, you mentioned Darwin. And Bonpland and Humboldt. Humboldt did his science because his family was rich. With his own money, he got on a ship because he was interested in nature, and then he went back to Berlin and to Potsdam, to high society, and told them the stories of his discoveries and so on. That was science 200 years ago. Today, science has a very different role and societal responsibility, without having fundamentally changed the profile of the scientist. So the only way to achieve this is by embedding science in a different context that allows for interdisciplinarity and allows for the kind of communication you call for.
Thank you, Professor. This is so fruitful discussion. I'm quite realistic, and I quite believe in human-centric environmentalism, and I believe in human, and we can solve every problem by the action and role of human being. And I think we have many wicked problems. Like I think we should have to adopt holistic and integrated method or approach to solve this kind of wicked problem in the social ecological system. And my proposal is something like, I mean, human has three character. It's economic, regulatory, and social. And according to economics, it's the hard true, but we are greedy animal. And we are afraid of regulations, and at the same time we have a moral something, ethical something that is social. And we can use these three elements, three human behavior to solve any kind of wicked problem in the social ecological system. So I'm quite, optimistic about this matter. Thank you.
I'm agree with the network and the need for integrating scientists from different disciplines to come up with general conceptual frameworks to tackle complex systems. I do agree with that, and this is the place for interdisciplinary. Back to the comment on the general public. This is clearly a major issue, how we deal with this communication. We got this problem that Holm pointed out. We are kind of nerds that likes doing other stuff that communicate with the public. But there's something that I think that is a fantasy, that we can communicate. I'm making a strong statement, I'm not quite sure, no? As most of the things that I say. There is a fantasy that we can communicate with the general public. What is the general public? What are we talking? There are different groups in the society, and I think that different scientists communicate better with different groups. And this derives from different things, from the topics we are dealing with some kind of connection with a particular group in the society related with many different things, the origin, the ideology, the circumstances or their career or whatever. I believe that we need to communicate with particular stakeholders, groups, with which we got at least preliminary connections or bonds. And this is very important. Thinking on this, because these links sometimes are difficult to construct, it is the importance of what we call make science more popular. Make science more popular, in general terms, is interpreted like, well, let's have programs where we open the university and let everybody comes, or write our paper in a cartoon format so we can read everywhere. Well, it could be. I think that the way to make science more popular is providing means for popular classes to get into university. What is a completely different thing. If you get people from aboriginal communities, from peasants, from, of course, for the rich classes of the society we already have, we got a direct connection with a group of stakeholders that is natural. It's because it's something related with the origin of these scientists. And of course, this is a long-term process. I think that is the most important thing. Having a local scientist working on a problem make a huge difference. We experience this in different cases. Having a local person that is part of the community generate a level of trust, provide these feedbacks with the community that are almost impossible to build from outside. Because what I want as a scientist is not just to go to the community to tell what is going on and what to do. I want to interact with the community. Because most of the time what happens is that I get a pretty biased view of what's going on in a system. So let's start for understanding what is going on a socio-ecological system of which I have a particular perception based on just these variables that I was able to collect, not all the ones that may be relevant for this. So these general public communications need to be seen perhaps on a more partial kind of approach, thinking on particular groups for particular scientists, need to incorporate these components into the science building, and probably need the feedbacks, need to work together on shaping the problems and defining the solutions. What we need to get the solution from there? No. We got a lot to put in a community to solve problems, but not just on a one direction approach. I go there, I gave my presentation, and I wrote a general public text, and that's it. Well, more comments? Well, I enjoyed very much the opportunity to be here. I didn't expect so many comments and interesting interventions that made me think on some stuff and try to go back and revise my thinking and my way to perceive this type of problems. I hope you get something from here, and of course, if you have questions, comments, don't hesitate on write me, send me an email. I answer every mail, so you will get an answer. Perhaps one answer could be, I don't know, and that's the most likely. And well, very happy to be here, and thank you for do not get sleep and be so participative in the. So I applaud you to you.